hope you're doing well when you watch this video. So this is kind of our first lesson, and I wanted to share it with you because I'm out of the classroom today. And every single question or statement that I say in this video, I want you to type out and email me, okay? And I'll highlight what those questions are as I go through this, okay? But again, I hope you're doing well. Let's go ahead and get started. So the first thing I would have asked you in class today is I want you to define science in your own words. So this is the first um, assignment I want to give you, okay? So I want you to type out what you believe science in your own words would be. The next time that we meet, I'll make sure to have that syllabus signed by you and your parents and those lab guidelines, okay? Also, I want you to answer these two for me. What do you think of when you hear the words observation and hypothesis? So just when I say observation, what do you think of? What do you think of when you hear the word hypothesis? Remember, this PowerPoint can be found on Teams under Files, Life Science B, General, underneath Files, okay? So and then finally, most mornings, every morning actually, we do something involving science. So what is one thing that you did this morning or another morning that involved science? And to explain to me why that is, okay? So what exactly is science? Well, let's pretend you're in a park and you see a man taking candy from a baby, and that's where the phrase comes from. It's easy as taking candy from a baby. Don't know where mom is or dad is in the picture. It's kind of obviously, and that's an old carriage, which is cool. But nonetheless, could science tell you if stealing candy from a baby is wrong? And the answer is no. Science can't tell us if stealing candy from a baby is right or wrong. Science, and this is what I want you to write down or maybe take a note on this PowerPoint. Science does not tell me about morality. Science talks to me about facts. Science talks to me about data. Science talks to me about observable phenomenon that we can observe and test and retest and make an hypothesis about and experiment with. But science doesn't tell me about morality. Morality comes from your worldview, your ethics, your faith. But science can tell me there's some things that science could tell me about that situation. For example, if there was a complaint filed with the police, they would ask what the suspect looked like. They would ask, what was he wearing? Observable facts. You could test sugar, the amount of sugar in the lollipop. You could study it, the effects of sugar on the body. And what if when you're young, a baby has this lollipop? Like, what's the effects if that baby eats a lollipop every day? What would be the health effects? Science can predict that based upon knowledge, but science can't tell me about morality. And so, what exactly is science? Well, this is a definition I want you to know. But this is what is science? Science is the investigation, okay, an exploration of, and this is what I want you to under highlight right here, natural events. Science doesn't deal with the supernatural. And the Bible's full of supernatural events. Jesus stopping a funeral procession, raising a son from the dead. Jesus raised people from the dead, raised himself from the dead. Jesus walked on water, fed 4,000 and 5,000 men at different times with just a little fish and bread. There's all sorts of miracles in the Bible, of course. Old Testament creation and fire coming down from heaven and the plagues. And so, but science doesn't deal with supernatural. Science deals with natural events that we can investigate and explore, and the new information from those investigations. So I would like for you to memorize that definition of science. So in general, there is three branches of science. Okay, the branches of science are as follows. Well, the first one, and some of y'all have taken these classes before, which is cool. And I don't have a pad to write on, so I'm gonna do this with. I'm actually just gonna write the letters because trying to type with a mouse, write with a mouse is pretty tough. But Earth and space is this one. Of course, the Earth, so Earth and space scientists, life science, which is what you're in now, and then this one is physical science. deals with fire and light and chemicals and molecules, and they all three work together. But these are the three major, like broad umbrella branches of science. And so you are in life science this year. So for example, this picture right here, which scientist would study this? Well, you could actually argue all three because there's soil here. Earth and space would be involved in, that. Also, physical scientists would be involved in that, trying to make possibly better fertilizers, chemicals, if you're trying to get this grass growing. Of course, this grass is alive, so a life scientist would want to study that. This sweet, cute little panda, absolutely adorable. This guy, of course, a life scientist would study that. What about fire and light and chemical reactions? Well, that's a physical scientist. Um, there's so many orbiters and probes that I believe this is called Juno, um, from NASA, and we're sending stuff. Our next big mission is going to the moon again and then to Mars, and it's exciting time in space travel. But this is Juno orbiting Jupiter. There's that big red spot right there, that huge hurricane on Jupiter, gas giant. But yeah, this Earth and space. So I mean, if you want to go into NASA, the foundation is basically Earth and space science. What about these pictures though, right here? If I was in class, I would ask you kind of what you thought these pictures were. But this, I had some fun. I've had some cool, uh, very creative, guesses here. But this is actually bacteria. Most bacteria is good. You're covered in millions of bacteria right now when you're watching this video. You have billions and billions of bacteria inside your gut called a microbiome. If you've heard probiotics, those bacteria are super helpful and good for you. This is actually, you might have seen pictures. This is actually a virus, and it's not COVID-19. Although I can eventually show you a picture of that. But this is actually an artist rendition of what it actually looks like of HIV, the virus that causes AIDS, human immunodeficiency virus. And so HIV, and so these little like circles right here are kind of like locks and keys, and basically this virus only attaches to certain cells. I believe it's CD4 cells. Memory is kind of a little faulty there, but that's a virus. But is bacteria alive? Well, the bacteria is alive, but viruses actually on the threshold of being alive. Like they do some things that living things do, but they don't do other things like reproduce. Viruses don't reproduce on their own. They have to hijack your cells to do it. So I want you, this is another question I want you to answer, okay? On that document that you're going to email me. But what are the three things a scientist would study in each of these fields? So tell me three things a life scientist would study, three things a physical scientist would study, and three things an earth and space scientist would study. The next part of this video, I want to talk to you about the following objectives. I want you to understand the scientific method. Okay, that's what we're going to learn about next. I want you to be able to contrast, which means find the difference between theory and law. And then I also want you to understand what bias is and how to avoid it. So scientific inquiry is actually a better way of saying the scientific method, and that's what you deal with in upper level courses of biology. But scientific inquiry is basically this process of us trying to study and explain the natural world and the evidence that we get from those investigations. So study, and we're trying to explain the natural world. So this is obviously the process of experimenting, asking questions, collecting data, analyzing the data, looking for trends, looking for patterns, reevaluating, possibly changing the procedure up, doing it again. So this is something that's sometimes confusing, not confusing, but just coming from first year and learning life science. But I want you, science is a process. It doesn't go in like a linear direction. So if I can write okay here, it's not like A goes to B and then every time after B you do C. That's a horrible arrow. That's not any better. Let's try that. Let's try that again. Good grief. I really need a pad to write on, but it's okay. So A leads to B, and B, leads to C. Okay, that's linear, right? A straight line. But as you can see, like, no, we might get to C and completely have to go back and revise A. We might get all the way down to like, F or something, step F, and then it's like, oh man, this is not working. Let's go back to B and figure out what's going on. So science is an ever-going process. One of the greatest examples of this is the discovery of penicillin. Penicillin is an antibiotic. Anti means against, bio means life. And so what's crazy about the story of penicillin, I'm allergic to it. A lot of people are allergic to it because it's been around for a long time when we've developed allergies to it. And I'm allergic to it, so I had to take other medications when I was sick with infections. But basically, Alexander Fleming was studying bacteria, and the story goes he basically left a petri dish that was growing bacteria like uncovered, and it got infected with mold. And what he realized the next day or so is that the mold was actually killing the bacteria. It was like clear around the mold, instead of like bacteria covering the petri dish. And he's discovered that that mold was killing bacteria, and from that he extracted the medicine penicillin, which has saved millions of lives over the years. And so, but he found that basically through an error in, scientific lab protocol, like there's a contamination, you try to prevent those. And so that's how he found that, which is pretty amazing to think about. And so the steps of the scientific method are the following. And let me get this off the screen. There we go. And so this is what, make sure you can write them down or whatnot. But here are the general steps. Again, this is not linear. This is just a general flow of science. So first off, I want you to observe and ask a question. Scientists are always asking questions. And so a good scientist is always asking questions. Why? What would happen if this changed? What would happen if this changed? Why does this happen? Why does this exist? Then you would do some research, figure out what's been learned about the subject. So then you would develop a hypothesis. A hypothesis is not an educated guess. I know people sometimes learn it that way, and it's not a bad way to learn it. I'm not trying to say anything bad about a previous teacher or anything if they've said that, but it's more of a prediction because you base it upon research. You're not just like randomly guessing something. No, you're basing it upon research about you're inferring from previous knowledge about what you think a good prediction would be. You experiment, and then you analyze that data. You draw conclusions, and then you communicate. In science, we definitely want to communicate our results so other scientists can, replicate the experiment, build on the experiment, find out more information. And so now I also want you to answer this question for me. So I want you to think of a question. So since we're talking about, being, you know, inquisitive and always asking questions, I want you to think of a question that could be investigated by using the process of science or scientific inquiry. So what is a question that could be investigated by using science? Okay, so those investigations are important. I also would like for you to read this slide. You can pause this video right here, and I want you, again, these PowerPoints are on Teams under files, but once you answer these questions for me about this eagle, again, this is just practicing science. So this is actually something I had to undergo. This isn't me, of course. That's not me, but this is actually a sleep study, and it was kind of crazy. You go to this office and they hook you up with all these electrodes, like measuring brainwave activity. They measure oxygen levels. That's why the guy's wearing stuff, those nostril and those tubes in his nostrils, and so it was kind of, I mean, she meant well, but they put you in this room. It's a decent, nice room, and the lady walks in and she's like, okay, well, I'm just gonna be in the other room watching you sleep if you need anything. And literally, that like didn't help me sleep. I was just like, I laid there for a couple of hours, like trying to like watching ESPN and stuff, because I was like, man, there's someone in the next room watching me sleep. This is awkward. And so, but the reason I show you this picture and tell you that story is because this is the process of science, right? Some people go to the doctor. I did, and yeah, I'm not sleeping well. I'm really tired all the time. Let's do a sleep study to figure out, and so that's what doctors really do. They're going the process of science. They hear complaints and they start investigating, trying to find answers and stuff like that. And so this is just generally the process of science. Again, we can modify, always go back and do things, but we ask questions, we hypothesize and predict what would happen. Then we test it out, we experiment, we analyze the results. Sometimes we have to go back and revise the hypothesis or modify the experiment. Maybe the experiment not so good, draw conclusions, and then we communicate it. So the differences between a theory and a law in science. A theory explains. So is an explanation. So it's more detailed for our purposes in seventh grade life science. It's based on knowledge gained from many observations. So some examples of scientific theory: Big Bang theory, how the universe came into being. Of course, the Bible doesn't necessarily agree with that per se. Evolution, theory of evolution, cell theory, theory of plate tectonics. All these are theories, and so theories are backed by a lot of good science. You know, it can't prove everything beyond a shadow of a doubt. Hence why they're theories, but nonetheless, they are backed by a lot of scientific evidence. And we'll talk about evolution and creation down the road. Um, a scientific law is a rule that just describes. It doesn't really explain why things happen. It just says it does. Like if an apple falling off a tree with Newton here, it falls. But why does it fall? Well, we don't get into mass. We don't explain, okay, gravity happens because of mass, and various things have gravity, and space time, and all sorts of crazy things with gravity. But that's just an example. So scientific law, right? So law of gravity, law of thermodynamics. An object in motion will stay in motion unless acted upon by another force. And so those are some examples of that. So I want you to now think about these questions for me, okay? Think about these questions for me. Do you think it's possible to prove a scientific theory is completely true? And I'll give you the answer to that one. Because no, theories can't be proved beyond all doubt. I mean, cell theory, we'll learn about it, but all cells come from previous cells is one of the tenets, one of the beliefs of the cell theory, the facts. And that's true. But the question then becomes, where did the first cell come from? And so that is an issue there. But I do want you to answer the second question. So answer this question for me. How do theories and laws compare? So compare and contrast theories, and I've been highlighting them, so I'll just stay with highlighting. Oh, don't highlight everything, bro. Don't highlight everything. How do theories and laws compare? So bias. Oh man, bias is so prevalent in the world today. So if someone told you this, pigeons are dirtier than you think. They eat trash and leave their droppings wherever they go. Pigeons also carry diseases. One time I was bitten by a pigeon when I tried to shoo it away, which must have been a really aggressive bird. I had to get a shot because the pigeon might have, cutting off the might have given me a disease. This is not me. I've never been bit by a pigeon, although that is a story to be told. But this person hates pigeons, right? Bias. And oh my gosh, you see this in the world today so much if you're paying attention. People, and we all have, are biased. We all have a way of looking at the world through like a slanted way. We don't give people the benefit of the doubt. We automatically shade more towards science or more towards the government. This time is very polarized that we're seeing in, COVID, right? Some people are shading towards certain politicians. Some people are shading towards science. Some people are believing their friends. I mean, we're all biased, and we all kind of want to believe what makes us feel good. So bias literally means one-sided, not having an open mind, which is against, to be completely honest, although scientists, obviously disregard this a lot, but we want to have an open mind. We want to have an open mind when it comes to the natural world. But you don't want to have an open mind with everything. For example, the person of faith, right? According to the Bible, the person of faith trusts God at his word, reads the Bible, and doesn't wonder like, oh, well, what if God changes his mind? Well, no, that's not what God's going to do. God is faithful and just. So here are some ways to prevent bias in science, and I want you to make sure you know these. So random sampling. So when you do a survey, I'm not just going to pick all males in the survey. That would be biased. Some sociological experiments done in the past trying to understand how morality is developed and how we learn, they only picked a certain age group and range, only 9 through 14 white males. I mean, that's not a good science experiment. You want to randomly sample. You want to repeat it over and over again. Science is all about repetition. And then blind studies, which means the subjects aren't sure what they're getting. That's kind of like drug tests, placebos. So for example here, let me tell you how placebos are crazy. Placebos, in science, if they're testing out a medication, let's say they're testing out a medication for, I don't know, anxiety, okay? So there's a medication for anxiety that's about to hit the market, and they're trying to figure out if it helps people manage anxiety, feel better, feel less anxious about the world around them, which is the world right now is very anxiety inducing. But nonetheless, Well, you would have two different groups randomly picked. You'd have group A and group B, and this is just generalizing, of course. But group A and group B both, they don't know if they're actually getting the drug. It looks the same, and it's a pill, so it doesn't really taste like much. But one group is actually getting the drug, and the other group is actually getting something called a placebo, which is basically a sugar pill, and they put various different things in it and stuff. But they do this study because here's what's crazy. Your brain is so powerful, and there's a video here that I'll try to show you in class. It's really well done by TED Ed, but your brain is so powerful that if it thinks it's taking something to feel better, you'll start feeling better. That's how powerful your mind is. Different chemicals are made when you believe you're going to be feeling better. Different neurons are firing. Different parts of the brain are lighting up in activity, and you actually start to feel better, which is crazy to think about because you're taking a sugar pill. But that's amazing. And so what they do is they study the pill's effects versus the placebo, and if it's within a certain statistical difference, and they'll prove like, oh, it works, or oh, it doesn't work and stuff. So it's crazy. I'll talk to you more about placebos in class. I'll try to show you a video. It's amazing how powerful the brain is. And so the last question here, again, we're trying to learn what science is all about. The last question for this first kind of lesson that I want you to answer. How could you change the question, which pizza tastes better, cheese or pepperoni, so that it could be answered using scientific investigation? Remember, we're all about studying data. How do you classify better? Better is an opinion. Better is a preference. You can't really classify better. So how could you change that question so it could be used for scientific investigation? So let me review at the end of this video. Let me review all the questions one time with you that I need to that email to me by the time we meet next. Okay. So define science in your own words. Make sure you sign the syllabus. What do you think of when you hear the words observation, hypothesis? What's one thing you did this morning that involved science? What are 3 things a scientist would study in each field? So 3 things a life scientist would study: physical science, earth and space science. What would they study? What is a question that could be investigated by using science? So give me a question there. How do scientific theories and laws compare? So compare and contrast those. And then finally, the last question, how could you change the question, which pizza tastes better, cheese or pepperoni, so that it could be answered using the scientific investigation, scientific inquiry? So again, I hope this video was helpful, guys. Thanks for watching it. Look forward to seeing you again. Until then, God bless. Hope you have a good day.